Hi everyone, this is Dr. Stuckey again. This is the last video I'm going to do for this week, but I'm going to go over problem 663. This is the one about the fire department and the ladder company. So some of you have asked what's the difference between a conventional ladder company and a tower ladder company, or whatever the two were. And I will tell you, I actually tried to find the answer out to that question for you. When I originally picked the problem several years ago, my brother was a firefighter. He was killed 8 years ago, 6 weeks. That was just 6 weeks before my oldest child was born. And I reached out to some of his friends to see if they could explain it to me, and I never got a response. So I don't know if they didn't know or they were just busy or whatever. They usually are actually super responsive when I ask them. So I don't know if anybody has worked in EMS and you know what the difference between those two are. I would love for you to let us know. It would be really interesting to find out. All right, there are two main keys to this problem. It's actually a fairly simple problem. I know you're thinking, what? Some of you, it's not simple at all. Oh, that wasn't what I wanted to do. I wanted to insert rows. The reason that I'm inserting rows here is that because we have to matrix. So what we are going to do, I'm going to copy and paste this data down here. And then I'm going to copy and paste this across, I hope. Yeah, all right. So we've got 7 companies. All right, so now what you've got to do is you've got to matrix this data. So you are given which companies are the two closest ladder companies to any alarm box. So the two closest ladder companies to alarm box 1 are companies 2 and 3. So you fill in a 1 for companies 2 and 3, and then all of the rest of these would be 0. Okay, I'm going to do one more for you just to show you, and then I'm going to talk about the other key to this problem. I'm not going to work the entire problem because some of that is something that you all need to figure out. All right. So alarm box 2, the two closest ladder companies are 3 and 4. Actually, I will do one more. Let's do alarm box 7 just for laughs and giggles. So the two closest ladder companies are 5 and 7. And again, you would fill in zeros for the rest of these. Okay. So your decision variables in this one are going to be binary. You do have to manually make this matrix based on this data. So I've done 3 rows for you. You can do the other 4. All right. Here's the other key to this. What you are trying to do in this problem is maximize the number of companies that are changed, but you have to keep at least 1 covering each alarm box. So what that tells you is you've got to flip the thinking on its head, right? Your decision variables are going to be binary, so that means you are going to end up summing the number of ones that are kept. You are trying to maximize the number of ones that are changed. That means you're maximizing the zeros, not the ones. So mathematically, you are going to inverse that. You're going to minimize the ones and maximize the zeros. So it ends up being a min problem, not a max problem, because again, what your decision variables are going to show you is when you add them up is how many are kept. You are trying to minimize what's kept and maximize what's changed. And so again, it flips the thinking of it a little bit on its head, but that's the key to this problem, is 1, the matrixing, and then 2, that your objective ends up actually being a min, not a max. So I hope that this was helpful. These little hints were helpful to you on this one. Again, if you have further questions, I'd be glad to help answer them. I hope everybody has a great week. If you need any further help, go ahead and email me. Thank you.